So, people, good evening and welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, having a good time. So, people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible and visible to everyone. Quickly, my dear students, quickly, everyone in the chats. All perfect? Yeah, all perfect? All perfect, yes? Wonderful. So guys, I would want you guys to call up all your friends because today we are going to do something really important, that is the basics of organic chemistry, right? The basics of organic chemistry we are going to do in the today's session. And this session is free for everyone, right? Okay. So everyone is most welcome in this particular session. Yeah? Perfect, perfect, perfect. So quickly give me some green signal from the chat so that I'll start the session. Give me some green signal from the chats, people, so that I'll start the session. No, Phoenix 2.0 batch classes will start from 18th of this month, right? This is just one session which is common for everyone, right? Okay, you can consider it as the demo session as well for the Phoenix 2.0 batch, right? But this is free for everyone. Perfect, guys. Perfect, perfect. So without wasting a lot of your time, let's get going. Let's get started. And in the today's session, my dear students, we shall be discussing the basics of organic chemistry. You know, your organic chemistry, you call it as the phobic subject, right? Okay, you call it as the phobic subject. But, I'll tell you one thing. If your basics are clear, if your basics are strong, then definitely this organic chemistry is going to be your favorite subject when it comes to your NEET preparation as far as the subject chemistry is concerned. Okay, right? So make sure your basics are stronger. Make sure whatever basics are required to start the organic chemistry, make sure all that basics is properly clear. Okay? So let's get going then. Let's get started with this particular session. Okay? And the ones who have not joined in the Phoenix batch yet, right, do get enrolled as soon as possible right after the session. Okay? Let me tell you, thousands of students have already joined the batch. Okay? So the ones who would want to join, do join right after the session, my dear students. Right? You can consider this as the demo session for the Phoenix 2.0 batch. And in that particular batch also, we are going to have the sessions on the bigger screen, etc., etc. Okay? And at the end of this particular session, I'll let you know more about this Phoenix 2.0 batch, which we are starting on Unacademy platform from 18th of this month, which is particularly designed for all the NEET 2025 aspirants. Whether you are the fresher or dropper, doesn't matter. Okay? Perfect, guys. So let's get going. Let's get started with the first and the basic topic which we have over here, right? And my dear students, what is it exactly? What is it exactly? What is it exactly? The first and the basic topic which we have here, that is charged species and their stabilities, right? Charged species and their stabilities. Try to understand what exactly I'm going to say. First of all, my dear students, if I ask you, what do we mean by the term charged species? What do we mean by the term charged species? My dear students, it's pretty much simple. Whenever you see an atom or a group of atoms, whenever you see an atom or group of atoms which have got charge on them, whether that charge is positive or negative does not matter. Whenever you see an atom or group of atoms having any sort of charge on them, what do you call that as? You call it as the charged species. You call it as the charged species. So any atom or group of atoms which have got charge on it, that charge can be either positive or negative, you call that particular thing as the charged species. Now, my dear students, For the charged species, we define a term. For the charged species, we define a term. What is that? That is VCD. VCD stands for volume charge density. So this particular VCD term, which I'm going to define in some time, right? Let me first of all tell you this VCD, this volume charge density, we define for what? We define this term for the charged species, right? We define this particular term for the charged species. Now, what is this VCD exactly? Let me first of all tell you, it stands for the volume charge density. It stands for the volume charge density. And my dear students, how do you define this volume charge density? It's pretty much simple. Volume charge density is defined as the ratio of charge on the species to that of size of the species. This is the first important thing which you guys are going to remember from now onwards, right? This is the first important thing which you guys are going to remember from now onwards. Volume charge density, it is simply defined as the charge on the species divided by size of the species. That's all. That's all, guys. That's all. One more important thing which I would want every one of you to remember. When I talk about volume charge density, what kind of information volume charge density gives me? My dear students, volume charge density gives us the idea about the stability of different species. It gives us the idea about the stability of different species. And let me tell you something which you are going to remember from now onwards. Volume charge density, it is inversely proportional to stability. It is inversely proportional to stability. What exactly it means? What exactly it means? Try to understand very carefully what exactly I'm going to talk about. My dear students, for example, over here, let's say I have got two species. This is species number 1. This is species number 2. Okay. Let's assume that there is negative charge on this particular species as well as there is negative charge on this particular species as well. And I am assuming the magnitude of charge on both the species is same. I'm assuming magnitude of charge on both the species is same. It is just their size is different. It is just their size is different. So if I compare the volume charge density of these two species, I am not going to compare it with respect to charge because charge on both the species is same. I'll be talking about VCD in terms of size. And you know, VCD is inversely proportional to size. More the size of the species, lesser the VCD. More the size of the species, lesser the VCD. More the size of the species, lesser the volume charge density. So if I ask you, among these two, which one has got more volume charge density? The one which has got smaller size. Simple. The one which has got smaller size. Okay. Similarly, my dear students, for example, this is one species, this is one more species. And both these species are carrying the positive charge. And I am assuming the magnitude of positive charge on both these species is same. I'm assuming magnitude of positive charge on both these species is same. Now, if I ask you to compare the volume charge density of these two, if I ask you to compare the VCD of these two, you are not going to compare it on the basis of charge. You will be comparing it on the basis of size. You'll be comparing it on the basis of size. Lesser the size, more the VCD. Lesser the size, more the VCD. Lesser the size, more the VCD. Right? Perfect, people. I believe it's clear to everyone. So first thing, volume charge density is nothing. It is a ratio of charge on the species to that of size of the species. And this VCD term, we define it for the charged species. Right? We define it for the charged species. That particular species whose size will be more, its VCD will be less. And what kind of information this VCD gives us? It gives us the idea about the stability of the charged species. Right? Remember, volume charge density, that is inversely proportional to the stability. Correct? I believe this is clear. To everyone. Okay. So this was my point number 1, my dear students, which I would want every one of you to remember from now onwards. And I believe this particular slide, it is clear to every one of you. Yeah? I believe it's clear to every one of you. Yes, in this batch, I'll be taking care of a lot of chapters of organic chemistry as well in Phoenix 2.0 batch, right? Do not worry, do not worry. Now, my dear students, there's a small term which I believe you all must be familiar with. What is that? Electronegativity. Electronegativity. How do you define the term electronegativity? What kind of information electronegativity gives us? That's something which I'm going to let you know right now. Okay? My dear students, as per the definition, which is very simple, electronegativity is basically the tendency of an atom to attract the bonded pair of electron towards itself. Tendency of an atom to attract the bonded pair of electron towards itself. What does that mean? You should know it. For example, let's say there's a single bond between A and B. There's a single covalent bond between A and B. If it is a covalent bond, what happens in covalent bond? Mutual sharing of electrons take place, right? There's a covalent bond between A and B, right? So there has to be mutual sharing of electrons. So if there is mutual sharing of electrons, I am assuming the bond pair to be at the center, right? Because there's a covalent bond. There has to be mutual sharing of electrons. The bond pair has to be at the center. But my dear students, if I assume electronegativity of B more than that of electronegativity of A, I'm assuming. Let's assume that electronegativity of B is more than that of A. What does that mean? That means this B has got more tendency to attract this bonded pair towards itself. That means this B has got more tendency to attract this bonded pair towards itself. So if I ask you whether this bonded pair will be at the center, no. This bonded pair will be shifted towards B. This bonded pair will be shifted towards B. Due to which electron density towards B will increase. Electron density towards B will increase. And that increase in electron density towards B, I'm representing by delta negative, right? So towards A, electron density has decreased, and that decrease in the electron density towards A, I'm representing with delta positive. As simple as that, right? My dear students, for example, there's a double bond. There's a double bond between A and B. Double bond means two bond pairs. Double bond means two bond pairs, right? I'm again assuming B is more electronegative than A. If B is more electronegative than A, what will happen? Both these bonded pair of electrons will shift towards B, right? Both these bonded pair of electrons will shift towards B, right? Due to which electron density towards B will increase. And that increase in the electron density towards B, I'll be representing with minus 2 delta, and here I'll be representing with plus 2 delta, right? Similarly, if there was a triple bond between A and B, okay? If there was a triple bond between A and B, and assume that B is more electronegative, so all the three bonded pair of electrons will shift towards B, due to which B gets minus 3 delta, A gets plus 3 delta, right? So electronegativity, it is basically the tendency of an element to attract the shared pair of electron, to attract the bonded pair of electron towards itself. As simple as that, right? Electronegativity, it is basically the tendency of an element to attract the bonded pair of electron towards itself. Point number one. Point number one. Now, people, what kind of information this electronegativity gives us? Let's have a look. Point by point, we'll discuss all the things. Point by point. The first and the most important thing, the first and the most important idea with which this electronegativity gives us, what is that? What is that? Electronegativity, it gives us the tendency of an element to hold its valence shell electrons. Electronegativity, it gives us the idea about the tendency of an element to hold its valence shell electrons. So basically, more electronegative the element, more is going to be its tendency to hold its valence electrons. So it's not going to give away its valence electrons easily, right? It's not going to give away its valence electrons easily. So I must say, more the electronegativity of an element, more is its tendency to hold its valence electrons, right? This is one more information which electronegativity gives us. At the same time, electronegativity, it also represents the negative charge holding capacity of an element. It gives us the idea about the negative charge holding capacity of an element. So electronegativity tells us whether an atom can hold negative charge properly or not. Electronegativity, it gives us the idea about whether the element, whether the atom can hold the negative charge properly or not. Okay? And do remember, more the electronegativity of an element, more is going to be the tendency of the element, more is going to be the tendency of the element to hold the negative charge. So more electronegative element has got more negative charge holding capacity. For example, let's say I've got oxygen, I've got carbon. Oxygen carrying negative charge, carbon carrying negative charge. Oxygen carrying negative, carbon carrying negative. If I ask you where is negative charge more stable, what you will see? You will see which element can hold negative charge, which element has got more negative charge holding capacity. And you know, more electronegative element has got more negative charge holding capacity. So I would say it is oxygen which has got more negative charge holding capacity. So do remember, more electronegative element has got more negative charge holding capacity. Remember it from now onwards. So if I ask you, where is the negative charge more stable? Negative charge will be more stable on oxygen, because oxygen is more electronegative than carbon, and more electronegative element, it has got more negative charge holding capacity. And as simple as that, more the negative charge holding capacity of an element, more stable is going to be the charge there. Simple. Yeah? Right, people? Very simple. Now, one more important thing which you should know. When we talk about electronegativity is inversely proportional to size. Generally, lesser the size of the element, more electronegative it's going to be. Now, you tell me one thing. On moving from left to right in the periodic table, what happens to size? I must say, size decreases generally. On moving from left to right. Similarly, on moving from top to the bottom, what happens to the size generally? Size increases. And you know, electronegativity, that's inversely proportional to size. On moving from left to right, size generally decreases. Therefore, on moving from left to right, electronegativity generally increases, because they are inversely proportional, right? Similarly, guys, on moving from top to the bottom, size increases. If size increases, that means generally electronegativity is going to decrease. Correct? So do remember this particular thing as well. Electronegativity, it's inversely proportional to size, right? Okay, as simple as that. Now, my dear students, electronegativity of orbitals also is defined. You have got s orbital, you have got p orbital, you have got d orbital, you have got f orbital, right? Since this is s, for example, this is your p, this is your d, and this is your f. Let's say this is the nucleus. Since s orbitals are closer to the nucleus, if s orbitals are closer to the nucleus, definitely their electronegativity is going to be more than that of p, than that of d, than that of f. This is something which again you are going to remember from now onwards. Okay? So first thing, electronegativity. It gives the tendency of the element. It gives us the idea. It gives us the tendency of an element to hold its valence shell electrons, right? More electronegative element has got more negative charge holding capacity. Electronegativity is inversely proportional to size. Electronegativity of orbitals is also defined, right? S has got more than P, P has got more than D, D has got more than F. Correct? These are few things which I would want every one of you to remember. Okay? These are few things which I would want every one of you to remember. Now, my dear students, if I talk about carbon in particular, carbon is the element which you'll frequently see in your organic chemistry, right? My dear students, if I say carbon shows sp hybridization, where I can be 1, it can be 2, it can be 3, right? So basically, if I talk about carbon in particular, carbon shows how many types of hybridizations? It shows sp hybridization, carbon shows sp2 hybridization, even carbon shows sp3 hybridization, right? These are the 3 hybridizations which carbon show. Perfect. My dear students, if I ask you, what is the percentage of S character in case of sp hybridization? If I ask you what is the percentage of S character in case of sp hybridization, how do you calculate it? Tell me first of all, how many s orbitals do you see here? 1 divided by how many total orbitals? 1s and 1p. So 2 multiplied by 100. So s character in case of sp hybrid orbital is 50%. What is the percentage of s character here? It is going to be how many s orbitals? 1 divided by total how many? 1s and 2p, total 3 multiplied by 100. So what is the value coming out to be? It will be 33%. So percentage of s character in sp2 hybrid orbital is how much? It is 33%. Similarly, if I ask you what is the percentage of s character in case of sp3 hybridization, how many s orbitals? 1 divided by how many total orbitals? 3p and 1s, 4 orbitals multiplied by what? 100. So percentage of s character in sp3 hybridization is 25%. Correct? As simple as that. This is something which you all must be knowing. Now, people, again one more thing. If I ask you, in case of sp hybridization, what is the bond angle? Remember them. Bond angle here is 180. In case of sp2 hybridization, what is the bond angle? That is 120 degree. In case of sp3 hybridization, bond angle is 109 degree 28 minutes. 109 degree 28 minutes. Now, people, try to understand very carefully what I'm trying to say. See, this is the percentage of s character. This is the bond angle. This is the bond angle data. On moving from left to right, what is happening to percentage of s character? On moving from left to right, percentage of s character is decreasing. 50, 33, 25. Percentage of s character is decreasing. At the same time, what is happening to bond angle? Bond angle is also decreasing. Percentage of s character is decreasing as well as bond angle is decreasing. Percentage of s character is decreasing as well as bond angle is decreasing. So can I say bond angle is directly proportional to percentage of s character? Can I say bond angle is directly proportional to percentage of s character? Right? As you can see over here. Perfect. And do remember, percentage s character is directly proportional to what? Electronegativity. It is directly proportional to what? Electronegativity. Perfect. Electronegativity. So if I ask you, that carbon which is sp hybridized, that carbon which is sp2 hybridized, that carbon which is sp3 hybridized, what about the electronegativity order of those carbons? If I ask you, electronegativity order, I'm asking you. That carbon which has got more s character will be more electronegative, as simple as that. So I'll say electronegativity of sp hybridized carbon will be more than that of electronegativity of sp2 hybridized carbon, which will be greater than that of electronegativity of sp3 hybridized carbon. What is the logic reason? Reason is over here, more s character. More s character means more electronegativity. That's all. That's all, people. Okay. This is one more point which I would want you guys to remember from now onwards. Perfect. Now, after this, there are few more things. There are few more things, guys. Just a second. This is something I told you. Bond angle, it is directly proportional to percentage s character, which is directly proportional to electronegativity. Now, my dear students, two things I'm going to tell you right now, which I would want every one of you to remember. Just two things. The first point which you need to remember, that is negative charge is more stable. Negative charge is considered to be more stable on more electronegative element. Negative charge is considered to be more stable on more electronegative element. Why? Because more electronegative element has got more negative charge holding capacity. I told you already, right? Similarly, guys, do remember one more point. Positive charge is more stable. Positive charge is more stable on less electronegative element. These are two very important points which I'm telling you right now. Negative charge is more stable on more electronegative element. Positive charge is more stable on less electronegative element. For example, have a look. Let's say over here, I've got oxygen carrying negative charge. I've got nitrogen carrying negative charge. If I ask you where is negative charge more stable? Negative charge is more stable on more electronegative element. More electronegative element here is oxygen. So negative charge is more stable on oxygen. Correct? Now, my dear students, let's say oxygen is carrying positive, nitrogen is carrying positive. Now, if I ask you, where is the positive charge more stable? If I ask you where is the positive charge more stable, I will say positive charge is more stable on less electronegative element. So positive charge is more stable on less electronegative element. As simple as that, right? As simple as that. You need to remember all these things. Okay? So negative charge is more stable on more electronegative element. Positive charge is more stable on less electronegative element. Do remember it from now on. Okay? My dear students, one more thing. One more point I'm going to write over here. What is that? I'm writing electronegativity. It is directly proportional to angle strain. It is directly proportional to angle strain. What it means exactly? This is again important. This is again important. See guys, try to have a look over here. Let's say I have got a 3-membered ring over here, cyclopropane. Okay, cyclopropane. Then for example, this is your cyclobutane, right? Cyclobutane. Similarly, for example, this is your 5-membered ring. This is your 5-membered ring. And over here, for example, this is the 6-membered ring. Perfect. This is the 6-membered ring. Now guys, try to understand. Try to understand. If I talk about this particular carbon, how many bonds this carbon is forming? This is 1 bond, this is 2nd, and there'll be 2 bonds with hydrogen. Correct? So carbon over here is forming 4 sigma bonds. 4 sigma bonds means the hybridization of carbon here is sp3. 4 sigma bonds means sp3. 3 sigma bonds means sp2. Right? Okay, 2 sigma bonds means sp. Perfect. Similarly, this particular carbon also, it is forming 4 bonds, 2 here and 2 with hydrogen. So this is also sp3 hybridized. Right? Even if I talk about this particular carbon, it's also sp3 hybridized. This particular carbon is also sp3 hybridized. If, my dear students, the selected carbons over here, all of them are sp3 hybridized. So what has to be the expected bond angle? What has to be the expected bond angle? Expected bond angle in case of sp3 hybridization is what? It is 109 degree, 28 minutes. Correct? It's 109 degree, 28 minutes. Now people try to understand. If I ask you, expected bond angle is 109 degree, 28 minutes. But what is the actual bond angle here? What is the actual bond angle here? You'll just see it is 60. Actual bond angle is how much? It is 60. Similarly, if you talk about this particular case, expected bond angle is how much? It is 109 degree, 28 minutes. Right? What is the actual bond angle? What is the actual bond angle here? Actual bond angle here is 90 degree. Perfect. Remember, whenever in a molecule, expected bond angle and the actual bond angle, they come out to be different. Whenever the expected bond angle and the actual bond angle come out to be different, we say that molecule is under angle strain. That molecule is under angle strain. Now, if I ask you, where will be the angle strain more among these two? Among these two, where is the angle strain more? My dear students, look at the difference. Look at the difference. Wherever you find more difference in expected and actual bond angle, wherever you find more difference between expected and actual bond angle, there only angle strain will be more. So I would say in case of first one, angle strain is more, and more the angle strain, more the electronegativity. More the angle strain, more the electronegativity. So if I talk about this particular carbon and this particular carbon, can you let me know which carbon, whether carbon number 1 or carbon number 2, which one is going to be more electronegative? I must say electronegativity of first carbon over here will be more than that of electronegativity of the second carbon. Right? Right, people? Remember it from now onwards. More the angle strain, that means more the difference between expected and actual bond angles, more will be the angle strain. More the angle strain means more is going to be the electronegativity. Believe this is clear? I believe this is clear. Similarly, one more thing, my dear students, which I'm going to let you know right now. What is that? Have a look. This is something important. 2 very, very, very important points I'm going to give you. My dear students, whenever you need to compare the stability of the charges, whenever you need to compare the stability of the charges on the elements which belong to the same period, right? Whenever you need to compare the stability of the charges on the elements which belong to same period, you will be comparing the stability of those elements on the basis of electronegativity. You'll be comparing the stability of those charges on the basis of electronegativity. What exactly am I talking about? For example, I've got carbon carrying negative charge, right? Nitrogen carrying negative charge, chlorine carrying negative charge. I need to identify where is the negative charge more stable. First of all, I will check whether these elements, they belong to same period or same group. Nitrogen, fluorine, they belong to, right? They belong to same period. They are the same period elements. They belong to same period. And whenever you need to compare the stability of the charges on the elements which belong to same period, how do you do that? On the basis of electronegativity. You know, negative charge is more stable on more electronegative element. Now, which one is more electronegative among these? Chlorine is more electronegative. So negative charge will be more stable here, followed by this, right? Similarly, guys, for example, you have got this scenario. Carbon carrying positive, nitrogen carrying positive, and fluorine carrying positive, right? Tell me, where is the positive charge more stable? First of all, you need to identify whether these elements, they belong to same period or same group. Again, these elements, they belong to same period. Right? And whenever you need to compare the stability of the charges on the elements which belong to same period, you'll be talking in terms of what? You'll be talking in terms of electronegativity. Right? Yes? Right, people? So tell me the answer of this question. Where is the positive charge more stable? I have told you already, positive charge is more stable on less electronegative element. So which is less electronegative? This one. Correct, people? Correct? Negative charge is more stable on more electronegative element. Positive charge is more stable on less electronegative element. Right? Okay? But remember, this rule you are going to apply to those elements which belong to same period. Right? Now, people, now comes very important thing. Whenever you need to compare the stability of the charges, on the elements which belong to same group, at that point of time, you are not going to talk in terms of electronegativities. At that point of time, you'll be giving your answer as per volume charge density. I have told you already, volume charge density, that is inversely proportional to what? That's inversely proportional to stability. And you must be knowing now, VCD is nothing. It is the ratio of charge on the species to that of size of the species. For example, you must be thinking, for example, let's say we have got oxygen carrying negative. Okay, we have got sulfur carrying negative. Oxygen carrying negative, sulfur carrying negative. Whether these elements belong to same period or same group, these elements belong to same group. And whenever you need to compare the stability of the charges on the elements which belong to same group, you'll be talking in terms of VCD. Now, tell me, where is the size more? On moving from top to bottom, size increases. So sulfur here has got more size. More size means less VCD. Less VCD means more stability. So where is the negative charge more stable? I would say negative charge on sulfur is more stable than that of negative charge on oxygen. As simple as that. So these are the two things, people, which you need to remember, nothing else. Right? Whenever you need to compare the stability of the charges on the elements which belong to same period, you will be talking in terms of electronegativities. And whenever you need to compare the stability of the charges on the elements which belong to same group, you'll be talking in terms of VCD, volume charge density. That's all. Now, time to do the questions. Carbon, nitrogen, oxygen, fluorine. They belong to same period. In the period, we give answer as per electronegativity. Since it's a positive charge everywhere, you know, positive charge is more stable on less electronegative element. So which is less electronegative? Carbon. Positive charge is more stable on less electronegative element. Carbon carrying negative, nitrogen negative, oxygen negative, fluorine negative. Again, same period elements. And you know, negative charge is more stable on more electronegative element. Negative charge is more stable on more electronegative element. Done and dusted, right? Look at the next one. Sulfur carrying negative, chlorine carrying negative. Sulfur carrying negative, chlorine carrying negative. Again, they belong to the same period. Talk in terms of electronegativity. This is group 16, sulfur, right? Chlorine, that's group 17. So 16 to 17, left to right, electronegativity increases. And you know, negative charge is more stable on more electronegative. Simple. Done and dusted, right? Similarly, people, oxygen carrying negative, sulfur carrying negative, Se carrying negative, Te carrying negative. Oxygen, sulfur, Se, Te, they belong to same group. You'll be giving your answer as per VCD. On moving from top to bottom, size increases. If size increases, volume charge density decreases. Stability increases. So I would say negative charge is more stable here, followed by this, followed by this. I believe you can easily solve these sort of questions from now onwards. Yeah? Right, people? Yes, I'll be teaching on smart board only in the app, in the Phoenix 2.0 batch, which is starting on 18th. Right? You need not worry. And I'll try to cover a lot of organic chapters this time as well, right? In that particular batch. Yeah? Perfect, people? All right. Now tell me the answer of these questions. Tell me the answer of these questions, guys. I'm not going to take more than 10 to 15 minutes. Relax. It is just the basic session. I'm just making your basics stronger. That's all. Tell me. Nitrogen carrying negative, phosphorus negative, arsenic negative, antimony negative. Down the group. They belong to the same group. Talk in terms of VCD. On moving from top to bottom, size increases. VCD decreases. Stability increases. So where is negative charge more stable? This is the order. Done and dusted, right? Right, people? Similarly, oxygen carrying negative, sulfur carrying negative. Oxygen, sulfur. Same group. More size, less VCD, more stability. So this is the stability order. Right? Now, people, tell me one thing. Single bonded carbon, double bonded carbon, triple bonded carbon. Right? Can I say this particular carbon has got more S character, triple bonded carbon? More S character means more electronegative. Right? So automatically that means this carbon is comparatively less electronegative. And you know, positive charge is more stable on less electronegative element. So this is the order. Done? Right, people? Similarly, talk about this one. Single bonded carbon, double bonded carbon, triple bonded carbon. Triple bonded carbon has got more S character, more electronegativity. And you know, negative charge is more stable on more electronegative. Right? Negative charge is more stable on more electronegative. Simple. Done and dusted. Tell me the answer of these questions. Tell me the answer of these questions. Okay? I'm going to keep on homework for you. You're going to let me know the answer of this question in the chats afterwards. I mean, in the comments afterwards. This is the question. This is the question. And over here, just a second, this is H. Over here, this is H. Okay, this is H here. Perfect. Leave it aside. Tell me the stability order over here. You should be in a position to give me the stability order. My dear students, this carbon carrying negative. Here is the carbon carrying negative, carbon carrying negative, carbon carrying negative. Now, you should be in a position to answer this one. You'll be talking in terms of what? Angle strain. Where is the angle strain more? In the first one. More the angle strain, more the electronegativity. Negative charge is more stable on more electronegative. So, this is the stability order. Right? This is the stability order. Yeah. Talk about this one. Positive charge is more stable on less electronegative. Right? So, this is the stability order. And this is your homework question. This is your homework question. I believe whatever things I told you right now, all the things are absolutely clear to every one of you. If yes, let me know in the chats. And my dear students, this was a session, right, which was just there to make your basics comparatively strong. See, in your Phoenix 2.0 batch, we'll be starting organic parallelly, right? So in order to do organic effectively, lot of basics are required, and this was one of the session in which I discussed about the basics which is required to start the organic chemistry. Yeah? Perfect? Right, people? Is every single thing clear? Say yes or no in the chats once. Say yes or no in the chats once, quickly. Quickly. All right, so this was a quick demo session of the Phoenix 2.0. In Phoenix 2.0, we are going to have the classes like this only on the bigger screen. Right after the session, we'll be sharing the PDFs, etc. with you, right? And all those students who do not know what this Phoenix 2.0 exactly is all about, let me give you the quick idea about this Phoenix 2.0 batch. My dear students, this particular batch, Phoenix 2.0 NEET English batch, this is for all the NEET 2025 aspirants. Whether you are a fresher, you are a dropper, does not matter. Whether you have studied once, twice, never studied, does not matter, right? This particular batch is for all the NEET 2025 aspirants. Okay, all the NEET 2025 aspirants. We are starting the batch on 18th of May. Okay. My dear students, your entire chemistry from the zero, from the scratch, will be done and dusted by me and HSP set together. And in this batch, right, already I'm taking physical inorganic, and there are some organic chapters, right, which are allotted to me in this batch as well. Okay, number one. Number two, your complete physics will be taken care by Yavar sir. Your complete biology will be taken care by Ambika ma'am and Pankhodi ma'am. You should be knowing who they are, right? And my dear students, the best part about this particular batch is all the chapters of your physics, chemistry, biology will be started from the basics, from the scratch, and people at the same time. All the theory which is there in a chapter, right? All the problem patterns which are there in the chapter, everything will be done and dusted in detail. Everything will be done and dusted in detail, right? Yes, everything will be done and dusted in detail. Be it the theory of the chapter, be it all the problem patterns which can be asked in a chapter, will be done in detail. The best part is, starting from 18th of May, we are going to complete the whole syllabus, entire syllabus in just 6 months. In just 6 months. The best part is, my dear students, we are going to cover 80 chapters of PCB, which is the whole syllabus, in 6 months. What does that mean? That means in 1 week, we are going to cover 3.5 chapters. In 1 week, we are going to cover 3.5 chapters in detail, right? In detail. And at the same time, once we are done with the syllabus completion, in 6 months, after that, we have dedicated 2 months for complete revision. And once we are done with the revision, then there will be 1 more month wherein you shall be writing what? You shall be writing the full syllabus mock test, and we are going to prepare those ourselves. Okay? And the best part is, since I told you you are going to cover 3.5 chapters in a week, right? The best part is, the Sunday of that week, you will have to write the chapter-wise tests. You will have to write the test basically. So whatever 3.5 chapters you have completed in 1 week, Sunday of that week, you will have to write the test of those 3.5 chapters. So all the chapter-wise tests are included. Every Sunday we'll make sure you write the test. Okay? So you need not to worry about that as well. Now, you must be thinking about the study material and DPPs. You are not supposed to study any book. We are going to provide you the study material which you are going to follow. Nothing else you have to do. All the DPPs which we share with you, just solve those DPPs. No need to follow any book, be it in physics, be it in chemistry, be it in biology. Okay, you need not to worry. Now, if any student misses any live lecture, you have got access to recordings as well, right? Recording will be shared with you. And the ones who are going to enter into this particular batch, the ones who are going to enroll into this particular batch, let me tell you, you will be having one-on-one mentorship with us. We'll be personally letting you know, right? There'll be one-on-one calls with you so that we keep on letting you know where your weaknesses are, etc., by analyzing your test scores. So we shall be analyzing your test scores, and we shall be letting you know where you have to improvise, what is the problems, etc., etc. So under one complete year, for 1 complete year, you guys are going to be with us throughout this particular journey. And the ones who are thinking, how do we get enrolled into this particular batch? My dear students, right now there is 50% off going on, right? And this 50% off is there for a couple of hours, I must say, right? And this particular batch, right now, you are just getting only for 5499 if you are taking plus subscription, right? If you are taking plus subscription, right? Apart from this batch, whatever batches are there in Unacademy, be it in Hindi, be it in English, be it in whatever language, for NEET 2025, you'll be having the access to all those batches absolutely free of cost. Absolutely free of cost. Okay? Right? So how do we get enrolled into this particular batch? See guys, this is first of all the video which you guys are watching in right now, basics of organic chemistry, right? This is the session which you are watching. You just need to drag it a little down, After dragging it a little down, here's a link. 1 year subscription for NEET UG. Click on this link. And once you click on this link, my dear students, here you have to select whether you are going to take Plus subscription or Iconic. What is the difference? In Plus, you get study material in the form of PDF. In Iconic, you get study material in the form of booklets. There'll be more mentorship sessions in Iconic subscription. That does not mean there won't be any mentorship sessions in Plus. There will be. But here, mentorship sessions will be often conducted, right? And my dear students, here you have to take the 12 months, right? Click on 12 months. Click on proceed to pay. Once you click on proceed to pay, you just have to put your number, mobile number on which you get the OTP and everything, or you can continue with the email, and at the rate of 5499, you guys are getting this particular batch right now. So right after this particular session, if you want to get trained by your Avengers team, by Unacademy NEET English team, you guys are most welcome in this particular batch. And my dear students, we are going to start the live classes from 18th of May, right? So right after this particular session, please get enrolled as soon as possible, right? Because tomorrow you are going to have this batch for 13 to 14,000, right? And at that point of time, if once the price hikes, then we cannot do anything about the pricing. Okay, so get enrolled as soon as possible. So this was the first session, right? Which was the demo session, because a lot of students wanted to know how exactly the classes are going to held, right? And this is how we are going to start the classes in our Phoenix 2.0 batch, right? There'll be live doubt solving as well. You need not worry about that as well. Okay? Perfect. Chalo. With this, I'm taking a leave, people. I'll see you in the live sessions. Till then, you take care. God bless you all and love you all. Bye.